In this lecture, we are going to see about the architecture of 8051 microcontroller. The 8051 microcontroller is one of the most popular microcontrollers in use today. The 8051 microcontroller is a general purpose microcontroller which was designed by Intel in 1980s. This microcontroller is an 8-bit microcontroller, which means it deals with data which is of 8 bits and it comes in 40 pins dual inline package IC and it operates at plus 5 volt power supply. Let's see about the features of microcontroller 8051. This controller provides many functions in a single package, that is CPU, RAM, ROM, IO, ports, interrupt logic, timers, etc. It is a 8-bit CPU, 8-bit ALU, accumulator and 8-bit registers, hence it is an 8-bit microcontroller. It has 8-bit data bus. It can access 8 bits of data in one operation. It has 16-bit address bus. It can access 2 power 16 memory locations, that is 64 KB each of RAM and ROM. On-chip RAM, that is 128 bytes, that is data memory. On-chip ROM, that is 4 kilobyte, that is program memory. 4-byte bidirectional input-output port. It has oscillator and clock circuits, 2 16-bit counter and timers, and it has 5 interrupt sources. Now this is 8051 microcontroller architecture, or we can say block diagram. It consists of various components. In this lecture, we are going to see the functions of each of these components. So let us start with it. Coming to the block diagram, this is the block diagram of 8051 microcontroller. In this block diagram, you can see that there are various blocks, and the block, what is represent, it is written inside the block. So this 8051 microcontroller, it has a 8-bit data bus and 16-bit address bus. Data bus is used to carry the data and the address bus is used to carry the address. Now also this 8051, it has 4 ports, and these 4 ports are as various blocks in this block diagram. This is for port 0. Port 0, it has drivers and latch. Both ports is having a driver and latch. We can say a buffer and a latch associated with it. So these are for port 0 and these are for port 1 and these are for port 2 and these are port 3. These latch and driver for port 3. These ports are 8-bit ports. These are bidirectional port. So bidirectional arrows are drawn here. 8 bits are there. So starting from P0 to P7. These are the 8 bits. These are the 8 bits of port 1. These are the 8 bits of port 2 and these are the 8 bits of port 3. Then we have different registers. This is RAM and ROM. For ROM, we don't have any address because we can only read that memory. No data can be written over it. So there is no address. There is no address register for it. But for RAM memory, we have RAM address register. So we can read and write the data or the program code into this RAM memory. Then we have registers like A register, B register, temporary registers are also there. ALU is there, that is arithmetic logic unit. Program status word PSW is there. Stack pointer SP is there and some special function registers are there. Also we have the data pointer, program counter, buffer, and program address register. Here we have timing and control and instruction register. In this control and timing register, control signals like P-SUN bar and ALE bar, EA bar and RST bar. So all these signals are provided by the timing and control unit. Then we have oscillator. Oscillator, we have the crystal is connected, and this oscillator is going to generate the clock pulses, and these clock pulses will be provided to the different registers. Accumulator, otherwise known as A register. The accumulator register acts as an operand register in case of some instructions. This may either be implicit or specified in the instruction. The A register has been allotted an address in the on-chip special function register bank. Hence, the operating speed with this register is comparatively faster. B register. This register is used to store one of the operands for multiply and divide instructions. In other instructions, it may just be used as a scratch pad. This register is considered as a special function register. Program status word, PSW. This set of flags contains the status information and is considered as one of the special registers. Stack pointer. SP is a 8-bit register used to hold an internal RAM address that is called the top of the stack. This 8-bit wide register is incremented before the data is stored on the stack using push or call instructions. Data pointer, DPTR. DPTR is a 16-bit register. It is made up of two 8-bit registers, DPH and DPL, that is data pointer high and data pointer low. Program counter, PC. PC is a 16-bit register. PC is the only register that does not have an internal address. Serial data buffer. The serial data buffer internally contains two independent registers. One of them is a transmit buffer, which is necessarily a parallel. The other one is a receive buffer. This is used for serial communication. Timing and control unit. This unit derives all the necessary timing and control signal required for the internal operation of the circuit. It also derives control signal required for controlling the external system bus oscillator. This circuit generates the basic timing clock signal for the operation of the circuit using crystal oscillator. Instruction register. This register decodes the opcode of an instruction to be executed and gives information to the timing and control unit to generate necessary signals for the execution of the instruction. ALU. The arithmetic and logic unit performs 8-bit arithmetic and logical operations over the operands held by the temporary registers TMP1 and TMP2. Users cannot access these temporary registers. These registers are internally used for handling data by the ALU. SFR register bank. The interrupt, serial port and timer units control perform their special functions under the control of the timing and control unit. Control registers. The special function registers IP, IE, TMOD, TCON, SCON and PCON contain control and status information of the interrupt, timer, counters and serial port. These registers have been allotted address in the SFR bank of 8051. Then oscillator. This circuit generates the basic timing clock signal for the operation of the circuit using crystal oscillator, the heart of the 8051. Synchronize all 8051's internal operations. A single machine cycle consists of 12 crystal pulses. A machine cycle consists of a fixed number of clock pulses. 8051 family needs 12 clock cycles for a machine cycle.